So guys, now I'm explaining the fourth test of the distribution, and the fourth test of distribution is testing hypothesis about difference of the two means with paired observation. For clear understanding, I would go direct to the question. Through the question I'll be explaining this kind of test, because it is not a kind of normal test like we have done in the testing one sample mean significance, or testing the difference of the two mean of the two different populations. It is the test of having the same population. How I can make you understand by this question. Read this question carefully and try to understand the basic theme of this test. A taxi company is trying to decide whether the use of the radial tires instead of the regular belted tires improves fuel economy. So this is an experiment that has been done for this company, by this company, for their cars. One situation is having a radial tires, and the other situation is having a regular belted tires. Improve the fuel economy. For that experiment, the 12 cars were equipped with the radial tires and driven over the prescribed test courses, and without changing drivers. The same cars were then equipped with the regular belted tires. Point to be noted that the sample size is sample elements are same, 12 cars along with the drivers. The main thing, the main difference is that these cars are having two different kind of experiments. One experiment was these 12 cars were fitted with the radial tires in one instance, and in other instance the same 12 cars are being equipped with the regular belted tires. So 12 cars are the same, 12 driver the same, but the difference of the experiment is the tire difference. So the performance is being recorded. Radial tires, gasoline consumption in kilometer per liter. The performance is being recorded kilometer per liter consumption of these 12 cars with radial tires, and the same cars, same drivers, kilometer per liter score of the belted tires. So do we have any kind of difference in between this? So this is the basically theme. It means that we can make any kind of such like of situation to test this hypothesis. Just like an example, if I'm giving to you of your class, that if I pick some students from your class, let's say if you have 25 number of students in your class. So let's say if I take some kind of test from you of your aptitude, there would be some score. You will be getting some score out of 100, and after that I set some kind of training for you 25 people, and after that training I take that test again. So you will be having some kind of different scores. So now to see the test that the generally this training has put some kind of difference before that training, and after that training the scores has been different. So this kind of test we can do from the paired observation. So I'll be doing the same test from the procedure. First of all, we have to see the procedure. So for procedure we go for the so this is our basically hypothesis procedure. 6 steps are there. Again, you can see that the null hypothesis is being set like that: mu A is equal to mu B. A stands for after experiment, and B stands for the before experiment. There is no difference between the mean of after experiment and before experiment of the sample. In our case, it is experiment not after and before case, it is experiment of the two different tires. So we can see that there is no difference between the mean of a radial tire experiment and journal belted tires experiment. So we can change it according to our question. So I am changing accordingly the mean of the radial tire experiment and general belted tire experiment of samples. So there is no difference between the mean of the radial tire experiment and belted tire experiment of the sample. And the alternative hypothesis, there is no difference. Let's see to check either the alternative is correct or not. At that 0.025, now see this, that the alpha is given to us as 0.025 level of significance. We can conclude that cars equipped with the radial tires give better fuel economy than those equipment with belted tires. So we can see that this is one tail testing, because it is saying that that the better that the radial tire gives the better fuel economy than the belted tire. So we can see that the alternative hypothesis is not unequal sign, it would be some kind of a one-sided tail test. Assume that the population to be normally distributed. So accordingly we will be setting our alternative hypothesis. So our null hypothesis is the two different tires have same results, but alternative the two different tires are not same. So I'm just changing it, this mu A, let take it as a radial. I'm changing it A with the R and B with the B, because there is a belted tire. So B is the B, and this would R would be for a radial tire. So radial tire mean is equal to the belted tire mean, where the alternative is not having the unequal case, it is having that the belted radial tire are much better having the fuel economy. Let's see again. It is clearly mentioned that the radial tire give better fuel economy. Then the radial tire would be higher than the belted tires. So that is radial tire, and that would be definitely more than belted tire. So that is our null hypothesis has been set. So this is our hypothesis statement. That is very much important thing to be set very wisely, and alternate I can explain here descriptively as well, that the radial tires have better fuel performance than belted tires. Belted tires. So that is our actually in fact the correct type correct form of our hypothesis. Alternate alpha is given to us, that is 0.025. I will be going according to my question, that is 0.025, where it is written 0.025. So I'll be taking alpha such like that. And the test statistics, here something different test statistics. The D bar divided by S, in S rather than S, I would be saying that it should be S of D, because we are taking sample standard deviation of the difference. D is for the differences. D is for the difference, and the D bar has been explained. and the variance of d bar is explained, we have to calculate the mean of difference and the standard deviation of differences, and the rest procedure is the same. So let's calculate the difference mean and the difference standard deviation. I'll be taking help from the Excel sheet again. I'm just deleting all these things. I'm having here the two cells. One would be the radial tire column, and then other would be the belt tires columns. So I will be taking the value from the table. So these are the value. I am just getting myself easy with this. So here I am taking the values from radial tires column. It should be very clear calculation. Let me put it all the values here. So guys, I have taken all the values in this Excel sheet. These are the radial tire scores. I've taken from this column, and the second column is this one, the belted tire scores, and I've taken all belted tire scores to this cell. So now I'll be calculating the difference D. D would be the simple difference of the radial tires minus belted tires. Let me check the null hypothesis or alternate hypothesis whether I am doing it correctly or not, because it is very much carefully dealt that the A should be minus with B or B should be minus with A. Let me clear myself again. So here the difference is R minus B. So R minus B would be our exact and true calculation. So I was doing correctly R minus B. So that is a radial tire score minus belted tire score. So this become difference, and this whole difference, all the difference is being taken here. So all the radial tire scores are being subtracted with the belted tire scores. Now I have to just get the mean and the standard deviation of this difference. So for that it's quite simple to have the variance average of all this. Average become 0.1416. It is positive difference, and in second phase I'd be doing the standard deviation, and the standard deviation of this all D or difference would be 0.1975. So 0.14167 is the mean. Let me write there, and this is your standard deviation. So mean and standard deviation has been calculated. Now I have to just look up to the my question. So we have calculated the mean. The mean is let me put instead of eliminating anything, I would be rather adding something here just to facilitate you. The mean was 0.142. Let's say if I'm going to round out my values. 0.142, while the standard deviation of the D was 0.197. That is 0.197. So this is a simple calculation of the mean of the D and the standard deviation of the D. The fourth step is having the critical region, and you know that the critical region is on the positive side because R minus B, R is better than B, having a greater than sign, so I would be letting my whole standard alpha on the right hand side. So that's why the left side would not be under consideration, because I'm taking my this alpha directly 0.025 completely, because the alpha is 0.025, it is not 0.05. It is not 0.05, otherwise I would be taking 0.05 on the right side, because it is given us the alpha is 0.025, so I'm taking 0.025 to the to my right side. So I will be taking this plus kind of side. I'm changing this graph according to my requirement. I've changed the values. I'm not taking it to the both side. I'll be taking it on just one side, and that is greater than to the plus side of t with 0.025 alpha, and degree of freedom is 12 minus 1, 11. So that would be my critical region, T alpha, that area of T alpha which is more than the T 0.025 with degree of freedom 12 minus 1, and by observing my table, T table, as I shown you in my previous lectures on the page number 244. So 0.25 is this, and 0.025 against the value of 11, degree of freedom 11 is 2.201. Again 0.025 is the alpha value, and the number of degree of freedom is 11, so that become this 2.201. So I'm taking this 2.201 here, so this is equal to 2.201 positively. Let me have some good visuals here. 2.201. So that is the value of our calculated tabulated value. Now we are come up with this calculation of T static, the normal value. We have already calculated the mean of the differences and the standard deviation of the differences. So now putting the values in this formula, I get this expression. I've put the all values of D, standard deviation of D, and the number of observation. I got this putted values, and by solving this we get this answer. That is our calculated T, and that is our tabulated T. We can see that the calculated T value lies above than our tabulated value. It is a little bit above, but it is more than this value. So according to my calculation, according to this practice, we can conclude that since the calculated value lies in critical region, that is 2.39 is more than 2.201, therefore therefore we reject the null hypothesis. We reject null hypothesis that when we reject null hypothesis, and obviously we are accepting alternate hypothesis, so we are accepting that the radial tires have better performance than the belted tires. So I can put all these terms in there as our conclusion. So since the calculated value lies in critical region, that is 2.3 is more than 2.201, Therefore, we reject null hypothesis that the radial tire have better performance than belted tire. Uh, Here we can show some proper results. Reject the null hypothesis and accept alternatives hypothesis that the radial tire have better fuel performance than the belted tires. So guys, that's how we can do it for the paired sample. Now I would request you to go through your exercise and do this exercises of paired sample on question number 18.27, 18.28, 18.29, 18. Because I have done this question on 18.31. So except this 18.31 question, that is last question I have done for you. Rest of the 4 question you should have do the practice, similar practice on your at your home, and whenever you find any kind of problem, you can ask me on my text, on my phone, on my WhatsApp, or email me. I'll be answering your each question and practice. So guys, this was the whole chapter of the T distribution. Here we have done these 4 kind of test in the T distribution, and that would be a very important part of your final term examination. So that's why keep practicing these questions again and again, and if you find any kind of query, you can ask me accordingly. Thank you very much. So nice of you.